Okay. First off, I'm going to be honest. I did make this video one time before this, but it did have to get deleted. So I will try my best to make sure I say everything that I need to say and I don't miss anything. Second, I do have only a limited amount of time on this camera because it's about to die, and it is like 11:32 at night, so I'm tired. But this video is going to show how to solve the first problem of our assignment and how to just get 100%. So first, what you're going to do is read the problem. Yeah, okay. So what you're going to do is first underline and realize everything that you basically need to know for the problem. And we'll just go off the problem just as you would. So first thing you need to know is what are the two types, and by that I mean like what is X and Y. So in the beginning of the sentence, one of the plants of the Mears Material Company makes aluminum and copper wire. There you go. The X usually, as I don't know, you could switch it. We've never done it before so far, so I'm not going to say you should. But usually the first type that you will be told is what X will be, and that will be Y. So the first type is aluminum, which is going to be X, and copper, which is going to be Y. And what you're going to do is make a table. So right now, so forget all this. All you know is that the X is aluminum, the Y is copper. So usually, so you read on each pound of aluminum. So it already goes to X. So as far as you know, there's nothing else. So there's blank for all the other relatable types of the X and Y. So all you gotta do is get an X table, and don't say make it I don't know, like 3 or 2 columns, rows, because you don't know how many you're gonna have later on in the problem. Make the Y, so on. Make the total, so because you need to know the end of the equation. Oh, I feel like I've already missed some stuff. I'm sorry. Oh, my neck. Okay, as we move on in the equation, it talks about saying each pound of aluminum, so we're talking about X, is required 5, I'm guessing that's kilowatt of energy. So as we said, I'm so sorry that this is bad quality. 5 kilowatts of energy, electricity. Gosh. Hold on a second, I'm so sorry. Okay. 5 kilowatt of energy of electricity. Sorry. So there you go. That's the first type of I wouldn't say topic, but category that you're going to focus on for X, aluminum. So as you go on your graph that you're going to make another row of electricity. You're going to go all the way down to cover X, because we don't know if it covers Y yet, but we know it covers X, so it's just all the way through. And it talked about 5, it requires, remember that word, it requires 5 kilowatts of electricity. So 5 kHW, guessing that's kilowatt, of aluminum. Okay? So as you go on, again, it talks about and a fourth of labor, fourth an hour of labor. Now also, again, like the word that we need to remember, it's required, requires. You need to remember that. So later on in the equation, but you want to make another one. So we made a category of electricity. You want to make another category of labor. So as you did for electricity, you made a little row for aluminum. Okay, we don't know right now that if copper is going to be about this also. So you're going to make a category, labor, and you're going to go on and put a fourth of an hour for aluminum. That's a fourth of labor an hour that someone's going to use. Go on from each pound of copper. So now we're going to talk about Y. So there you go. Copper requires, so again, there's that word, so it's relatable to aluminum, requires, requires 2 kilowatt of electricity. So now, like, you can already tell that it is, but as an example, you don't know if it's going to relate to Y after it talks about X. So we didn't know if it was going to relate to copper, but now we know. So, like, let's read on the question. Of electricity, copper is going to require 2 kilowatt of energy, or electricity, I'm saying energy. So there you go. And still, remember the special word right now, requires. So, copper requires 2 kilowatt of electricity and half an hour of labor. So we go on, we talked about a fourth of labor, or hour of labor of aluminum. Copper is going to require half of an hour. So labor, you get the idea. Production, sorry, I didn't zoom in. Production of copper, wire, and aluminum. So now it's talking about both copper and aluminum. Now I don't know why they switched. That might be something to catch on, or it might have been a typo. I don't know. But like, let's just switch it for now. Aluminum and copper, the production of those two, is restricted by the fact of the raw material are available to produce. Let's move this paper a little bit. To produce at most 100 pounds a day. Now, for this can get confusing. So, as you go back in the sentence, we talked about copper and aluminum. Like I said in the beginning, aluminum is X, copper is Y. They didn't give us any number, so you have to assume that all they're talking about is just that type. So we're talking about X and Y. So we go down, and we talked about production. So that's going to be a new category that we're going to get. Forget profit. Forget that right now because we haven't gone on. Production, we're talking about X for aluminum. We're going to talk about Y. And you want to just add that because it talked about and. So it's talking about both of them. Now, as I talked about the special words, this one for, where were we? Production of copper, wire, and aluminum is restricted. That means that, it's less than or equal to. So it can't go above it, or lower. It can't go under 100 pounds a day. So as you go in, now the way I know this is notes that we took in class. So up to or at most, that is related to restricted, or does not extend. That is the less than or equal to sign. So when you go on your graph, zoom out here a little bit. When you go to your graph, talk about production. Let me zoom out a little bit more. When we talked about production, we had to talk about X for aluminum and Y, copper, is restricted to, so less than or equal to, 100 pounds a day. This is your full first equation so far. So we know that this is one of the constraints, and I'll explain what a constraint is later on. But just remember, this is your first equation. So you go on in the problem, get the pencil or the pen. Electricity is limited to 400 kilowatts a day. So limited to is, again, at most, or up to, like we talked about, at most, up to, does not extend, etc. It is limited to 100 kilowatts a day. Electricity. Now at that point, it's talking about both copper and aluminum for the whole category of electricity. So electricity is limited to, which is the symbol less than, okay, less than 100 kilowatts a day. So this is your second full equation right here. And like, we've never done anything where it says like subtraction. We haven't gone through that yet. So just right now, assume that everything is added on, just so we remember that. So we talked about electricity is limited to 100 kilowatts a day, which we talked about, and labor to 40 people hours per day. And as you can kind of like get the idea, It's talking about limited to. It's talking about labor is limited to. You gotta just like go a little bit of English and like connect the words that labor is limited to 40 people a day. So this is your first or your third final equation. We're talking about labor, the type or the category. We're talking about both of them. So we're just talking about labor in general, limited to, which again you can kind of figure out that. Talked about kilowatts being limited to. Now we're talking about labor being limited to. It's the same thing, so it's going to be the same symbol. Now, you don't feel confident, check back on your notes or look it up online. It's like everyone else does, and make sure that you're right. But if you feel confident, it's just about what the symbol is going to be because it's related to the same wording. So labor is limited to 40 hours a day per person. Okay, so as we go on, the equation talked about 40 people per day. If the profit of aluminum wire is 25 cents a pound, so we're talking about a brand new category, which is profit, which again, probably already saw that. Excuse me. Talked about aluminum wire is 25 cents a pound. So aluminum X is 25 cents a pound. So you got that. Just connect it. I didn't mention this, but as you can probably already tell, if you see any numbers, and sometimes there's going to be some equations where they don't have numbers, they're just going to have words, and you got to actually read. I know it sucks, but you're going to have to actually read and know all the numbers. We got underlined any categories you see, any numbers, any special words, just so that can help you make graphs like this so you don't get lost or you don't miss something. Because some stuff like that, like just some sentences that are not underlined at all, either the sentence is not straight up important or you might be missing something. So that's just a thing to think about. Okay, so profit, so new category, profit. For aluminum, X is 25 cents a pound. Got that. And the profit, so same category of copper, so Y, is 40 cents a pound. So you put that next to 25 cents. It's copper is 40 cents per pound. So these are all of our constraints. Again, I'll talk about what constraints later on, but just know that basically a constraint is something that is equal to something. But actually no, I will go on and then I'll explain it. So how much of each should be produced so each aluminum and copper should be produced daily to the maximum. You have to remember this at the end of each equation, if it's a maximum or minimum profit and what is the maximum profit. So what is the highest profit we can get out of selling both of these together? So this equation right now, so really forget this, cannot finish. Like you don't know if it's less than, greater than, or something to any profit. So all you gotta do is equals C, which C mainly means cost, which is profit. Sometimes you have to verify that on equation, but this one, all you gotta know is what will be how much of 25 cents and 40 cents times how much aluminum and copper we sell can make the most profit. So all you gotta do is equal C or P, whichever you want to get. So what I said, what is a objective? First off, a constraint. Constraint is, just to sum it up from what I've been thinking, it's whatever equals something or less than, greater than, etc. But also, I would think is all the equations. So we talked about electricity, labor, profit, production. Whatever one is asked at the very end. So we're talking about what's maximum profit. If it's profit, it's an objective function. That is our objective, to find out how much of aluminum and copper we can sell to get the most profit. That's our objective. Everything else is a constraint. It's just there. That's going to help you figure out what we're going to find out what of the maximum profit. So all these that is not have an equal sign. No, you shouldn't say that. That might screw some people. But if it does have an equal sign, it's a constraint. If it has an equal sign, we have to find that because that's our objective to see how much profit we can make. So, give me a second because my computer turned off, and I have 15 minutes left in this camera. So we're gonna go pretty fast. I've already done 15 minutes. So, as you can tell on the PowerPoint that we made, everything I didn't write down the whole entire paragraph. Everything that's underlined, basically I put on here. So we talked about two types, which is aluminum and copper. Each pound of aluminum requires 5 kilowatt of electricity and 1/4 of an hour of labor. Again, so we talked about that. Aluminum talks about 5 kilowatts of electricity, 1/4 of an hour of labor. Then it goes to copper wire, requires 2 kilowatts of electricity and 1/2 an hour of labor. Copper, 2 kilowatts of electricity, 1/2 an hour of labor. You get the idea. Copper, now, I did actually notice this when I made the first video. Copper wire and aluminum wire is restricted to 100 pounds a day. Copper wire and aluminum, sorry, that's a screw up on my part. Copper wire and aluminum is restricted to 100 pounds per day. Electricity, focus on here. Electricity of the factory is limited to 400 kilowatts a day of labor, and of electricity. Sorry, and labor is limited to 40 people per day. That's kind of 40 person hour per day. You don't have to you won't get your points taken away for not knowing how it's worded. But that was pretty confusing. But my partner and I got the idea. So, talked about that. So we talked about, again, like it's on the PowerPoint, and what we just talked about. Electricity is restricted to, or is limited to, 400 kilowatts per day, and labor is limited to 40 hours per person per day. Aluminum, how much aluminum costs per pound is 25 cents. And how much copper wire costs per pound is 40 cents. For the profit, 25 cents for aluminum, 40 cents for copper per pound. You get the idea. So, when you talk about the problem, just sum up the whole entire paragraph of everything you underlined in this. So basically, as you can tell, this is exactly what we just made, but on a screen. But also, we talked about what the symbols are for this graph. So X, Y, and C. X is number of pounds of aluminum wire, or aluminum gel. Y is the number of pounds of copper wire, or copper in gel. That's Y. And C is the profit. A equals C, profit. You get the idea. Anyway, so I talked about words are fun. Objective function, and the constraints. Our objective is to find the max profit of how much we can sell for aluminum and copper. So this equation, 25 cents per pound plus 40 cents per pound equals C. 25 cents, or C equals 25 cents per pound, which is X, which means 25 cents aluminum, which X equals aluminum, and 40 cents of Y, which is copper. Yeah. That's the objective. We need to find how much we can get out of that. Constraints are these two problems. Sometimes equations would tell you what it will equal, but mainly, this is to show, you'll see later on the graph, it's to show which quadrant you will be in, and it'll basically show, hey, you're going to be in the first one, because you can't really receive your product. Well, actually, you can't give out your product. So this I'll explain later, but that's going to help you a lot. Just these two. But this will be, again, I don't really have to explain it. You get the idea, because I have 10 minutes left. 1/2 an hour of labor and 1/4 of an hour of labor, 40 hours per person. 1/4 an hour of labor, 1/2 an hour of labor, 40 hours per person. 5 kilowatts plus 2 kilowatts, aluminum, copper, 400 kilowatts per day. copper or aluminum and copper, you can only use 100 pounds per day. You get the idea. Like I'm sorry, I have to go a little fast on this. What I said about the graph. Okay, so the graph is, let me make this a little bigger, just for our sake. The graph, like I said about x and y, what I said about those two equations that you'll get, this will basically show like, hey, out of those two equations, this is going to be what you're going to have to focus on. Just, it'll help you a lot more. It's hard to explain, but like, if you go in any other ones, you're basically receiving product, well actually no, you're giving product and receiving, which that companies don't work like that. When you add all your equations in from the, the constraints, when you add all these in, it will make a lines, and it'll show you every shade part that covers. And when you go on Desmos.com, it will really help you on this. It will show like the main shaded part that this this camera's about to turn off and I'm talking really fast. It will show you your feasible region, which is basically the shaded region where all the equations focus on together. And with this, you will find the points of every line or equation that connects, and these points, all 5 of these points, you have to remember to go on. Which these are called your vertices. When you find vertices, so we had 5 points, you'll connect them in the objective function equation, which is what we talked about right here. So x and y, x, y. You're going to put in all the equations, and these are all the answers you're going to get. And like we said, you have to remember the maximum profit. That's what we had to focus on in this equation. So out of this, the maximum profit of the vertices, which is the points, the highest amount of money that we got was $34 per pound, which was 40 and 60, which again we talked about x and y of aluminum and copper. So it really means 40 pounds of aluminum, 60 pounds of copper. Go through the objective function of 25 cents of aluminum per pound, 40 cents of copper per pound, equals $34. That's the highest we got out of trying all these vertices. So the end, your recommendation, so basically to sum up what you got, you're going to say the maximum profit, which we got, was $35 per pound. The way that we found that was we looked at the vertices of 40, 60. That was the point of, excuse me, 40, we found from the vertices was 40, 60, which was 40 pounds of aluminum wire and 60 pounds of copper wire. So that was the vertices of the point. So the point was this one. That was the highest point where we got the highest profit of selling copper wire and aluminum wire per pound for the certain amount of a cost of 25 cents of aluminum per pound and 40 cents of aluminum per pound. That's how you get your answer. So again, some questions were asked like, what is the like, it doesn't really matter this one, but like, what is the smallest amount of profit we get? So that would be, smallest one would be 0 pound. We got $0, which was 0, which was 0 pounds of copper and 0 pounds of aluminum, which makes sense. Basically, they didn't really do anything, which doesn't really matter in this equation, but you get the idea. So basically, to sum this up in like 2 minutes, go through the equation, underline everything that you found, find the types, or first find x and y, which was aluminum and copper, find the types of, like, I don't know, the topic, or the, like, electricity, labor, profit, production. Find all the categories. There you go, categories. I forgot the word. Find all the categories, underline all of them, show how x and y can relate to all of them. So 5 kilowatt, 2 got, yeah. Then at the very end, look at the special words, so limited to, requires, and see how that can relate to like less than or equal to, or greater than or equal to. So you can get your equation, and type that in to, you get all the equations. So I'm sorry. Know all the equations so you can make the graph, so it can all be related. Know what x and y is and what the objective function is, and what it actually stands for. Know what if you need to know the maximum profit, lowest minimized profit. It doesn't have to be profit. It could be something else, but you need to know what the max is and the smallest is. Know what the objective function is and the constraints, and like you probably get the idea, but know like which quadrant you're going to be in. This will just help you out. It will. Graph it out, and I have 2 minutes, but basically look at this, just a symbol. If it doesn't have a line, the line that you're going to make is going to be dotted. If it does have a line, it's going to be a solid. And also to know which part it's going to be shaded, look at this symbol. If you turn it counterclockwise, if it looks down, it's going to be shaded down. If you turn it counterclockwise and it's going to be pointing up, it's going to be shaded up. So there's an idea right there. You're going to graph, got a minute, sorry. You're going to graph, find all the vertices of every point that all the lines cross of the shade area, which is the feasible region. Connect all the vertices with the objective function equation, put x and y in, find the max or smallest and how that can relate, and then realize what was the highest, what point it was, and why. And there you go. And I'm sorry this was really fast, but I have less than a minute. And yeah, that was it.